Hello, engineers, and welcome back to the DevSecOps series. So today we are going to cover the topic which is called as DAST, Dynamic Application Security Testing. And in this episode, we are going to learn about what are the basics of DAST, what things does it detect, okay, when in the SDLC is it used, and what are the tools we can see which are widely used for DAST purpose. Now, in our previous videos, we have covered what is SAST and SCA. So if you remember, SAST and SCA both heavily focus on the code base, the application code, as well as the package files, the third party libraries that you consume in your application. Now, DAST, as opposed to SAST and SCA, is majorly focused on the running application. Okay, it is not static, it is not composition analysis, it is dynamic. Okay, so what it will focus on is whenever your application is running, is in running state, then it would kind of test it. So that's how is the difference between DAST and SAST or SCA. So let's see what we have covered till now. I will just show you this stuff wherein in our GitHub repo you can see that we have covered almost 9 topics as of now. SAST, SCA, threat modeling, DAST, is what we will cover: CVE, CWE, CVSS, EPSS. And here is the link to each video. You can go over here, and this is where you can find the project uh, that you can work upon. Okay, you can see the SonarCube integration and all of this stuff using SAST. I mean, using SonarCube for SAST, and some of the DevSecOps interview questions. Now, in our recent times, we have also started podcast, which are generated by AI. So, if you just want to listen to, you know, like learn some stuff. So here you can see we have created the DevSecOps podcast, as well as we have covered the SaaS topic in it, and the same is available in English as well. So that's how we have done this thing. And in our playlist, if you can see, we have covered almost 15 different videos. Where is it? The DevSecOps series, this one. So almost how much? 15 we have covered. In our latest video, we have released a song which is for DevSecOps for the future's sake. I hope you would enjoy this one. We have covered GitHub Advanced Security, dependency check for SCA. Okay, these tools were done. Then SonarCube is done. Okay, what is SCA, what is SaaS, threat modeling, and all this stuff. So you can navigate to these particular channels, and you can see what we have done up to now. Okay, so let's begin with what is DAST, Dynamic Application Security Testing. So what are we going to cover in our today's discussion is, first of all, what is DAST. Okay, then how DAST works, different types of vulnerabilities that we can detect using DAST tools, then what are the benefits, limitations, popular DAST tools, and a comparative study between DAST versus other security testing methods. So in it, we will learn what is the difference between IAST, SAST, and DAST, and other stuff, so that you could get a holistic view of which tool should be used at what time of the SDLC or what phase in the SDLC. So let's begin with the next slide. So what is DAST? First of all, DAST is nothing but the abbreviation is Dynamic Application Security Testing, and in it, what we do, it is a type of black box security testing. Okay, in which what are we going to do is to identify vulnerabilities in a running application. So imagine you are writing a code. Now, once you build that code and run it, that's a running application. So code versus an application. Now the application runs on a particular kind of environment. Either if it is a Windows application, it would run on Windows kind of configuration. If it is a Linux based application, it would run on Linux configuration. So there is a difference between how the application runs, okay, based on how you are building it. So let's say it's an executable file, okay, which is uh, packed with DLLs. So how do we run that? So that requires either Docker or operating system or virtual machine. It could be run anywhere. So when this application is running and it is being accessible by either web browser or it is hosted on the operating system itself, that's when we want to test it. Okay, it is not in a stop state. We are not looking at the code. We are only going to attack the application directly. So, unlike SAST, which analyzes the source code, what we will focus is DAST test application without any knowledge of the internal code base. So, even if you cannot see the code, you can directly run different kind of attacks. Okay, you can simulate how an attacker would interact with your application from the outside. So that's what we are going to learn. We are going to do in so that scans the application in its live runtime environment. Okay. So either it be any operating system on production, QA, or staging environment. And what it does is tries to find vulnerabilities by sending crafted input and analyzing this output. So it would test your application. Okay, let's see if it is kind of entering kind of a string. Okay, then it malforms that string and adds some special characters. Okay, now how your application is behaving in that case, this is what it would test it. So I hope you got to know what are we going to do. Okay, once the application is running and served or it is deployed, then we will kind of send some inputs to it and then try to check what is the output of it. Is the application going to break? Is it behaving in certain different way? That's what we need to check. So now how does DAST work? There are three different or four different kind of stuff that we can see over here. So let's see what is crawling the application. Okay, what do we mean by crawl? Okay, crawl means move over here and there. So what it does is the DAST tool explores the web application, okay, just like a browser or user would, to discover pages, forms, and parameters. So just as you go on Google and type something and you go on this page and that page, okay, you get to see different pages as such. So let's see. Uh, if we talk about, here we go. Okay, we open this particular URL. Okay, now what are we going? This is the first page. Now we would go on this page. Okay, so what we did, we crawled on this particular URL. We went to this URL and we now can see this particular UI. Now what would happen if I go to this page? Okay, it again goes to another URL. Okay, now again another one, again another one. So these are different things, I mean URLs that we are hitting, and that's how we can get to know that we are kind of crawling on this web application. Okay, so branches, if we go to this thing, so you can see the changes in the URL. So what does crawling means is that we are kind of going from one page to another page, just like a person would do, so that we can discover the pages and the different parameters that we can type in this particular URLs. That is one thing. The next is what it would do is it would send malicious input. Now the tool then sends various types of payloads. Okay, what is a payload? So if you again go over here and okay, let's see if there is anything we can type over here. Okay, so here we can say test file. Okay, if we give enter, so do we get anything? I'm not sure. It is showing something else. Okay, so now if I try to input at the rate star this one, and if I now try to press enter, nothing is going to happen. So now what is this? This is kind of trying to inject some malicious or some malformed scripts or symbols. So this is what I'm kind of doing to inject. Okay, so injecting these things is what we are kind of focusing when we talk about uh, sending malicious input. So this is how we are kind of going to simulate different kind of common attacks techniques which are generally seen. So what are these different techniques? We have seen SQL injection, in our previous videos, as well as cross-site scripting. What is that? What is CSRF, cross-site request forgery, command line injection or command injection, and directory traversal. So these are the different things, that this dashed application will test our particular application for. So this is how hacker would like to explore your web application, okay, based on certain malicious inputs. Then what do we see is monitor responses, is what DAST application would do for DAST tool. Sorry. So DAST tool analyzes how the application responds to these inputs. Okay. So if you have tried someday to open a lock without a proper key, so what do? You would put something, wire in it, and if you try to open it, so see if it is opening by the wire. Okay, no, if it's not opening by the wire, let's try uh, a knife instead. So if you try again with the knife, okay, let's say if it is not opening again, then you would like to use another type of key, okay, which is not uh, even close to opening that thing, but you would still try. So what are you doing? You are kind of injecting different inputs and checking if this application behaves certainly in a different manner, okay, or if it opens, okay, by doing this stuff. So that's what we are trying to monitor after we inject these particular inputs. So now if unexpected or unsafe behavior is detected, that is revealing database errors, executing script, a lot of things can go wrong, and then this tool now will flag it as a vulnerability. So there is a way that lock should behave, but if trying to open it with different type of material or different type of tools, if it behaves in a certain way, then you will need to report that thing to the lock makers, okay, or the manufacturers of this particular lock, that if I try to open it with this screwdriver, now it is opening, okay, or it is being destroying the internal circuit, and then it opens later on. So that is what we will do in the monitoring phase, and then we will report this thing. So now a vulnerability report is then generated that include vulnerability type, severity, evidence of the exploitation, how it was exploited, and then recommendations to fix that particular thing. So these are the few things that we get to see in DAS applications. So first is what? Uh, it would crawl the application, then try to send malicious inputs, then it would monitor how it works or how it behaves according to the response it gives, and then it would report it in a form of vulnerability report. So this is the life cycle in DAST. Next is what? I hope you got the points. Okay. If not, you can write it in the comment section. I would again explain it in a different manner, let's say, for example, and I would like to try it with different examples, and I would also upload it in the podcast section. So you can, later on, if you don't get the clear idea from this video, you can watch the podcast as well, which is assisted by the AI. So now what are the different types of vulnerabilities that we can see after DAST performs its analysis? So first is the SQL injection, then cross-site scripting, then directory or path traversal. Sorry. Then if your application can perform a remote code, okay, someone is sitting somewhere and then it injects some malware and then it is kind of trying to execute that one, your application is not safe. So remote code execution is one more harmful way that it could destroy your entire infrastructure. So then insecure HTTP headers, and then security misconfigurations in your application, if it can go in a debug mode or something else. Okay. Then broken authentication or session management. If you have heard about um, session hijacking, so what it does is, if there are any cookies that are stored for your session, so someone can copy those cookies and then paste it or store it in their web browser, and then what would happen, that session that you have created would get replicated in their application as well, or in their browser as well. So session management, if that is done or not, it would also check that one. And then again, unvalidated or open redirects, if if you kind of go on certain page and then it redirects to something else, so that is what would be detected as well. And then insecure direct object references, IDOR, is what it would again detect. And XML external entity attacks. So these are the different types of vulnerabilities you would get by DAST. Some of them you can find it using SAST tools as well, but DAST, it would test it on the running application. So now here you are not looking at the code. Okay, you have zero visibility of the code, but you are what are you trying to do now? You are trying to inject certain type of attacks that you already know or that are already available, and then try to see if there are any kind of different responses from this application. So we are not looking at the code, we are directly hitting the application. So that is the major difference between DAST and SAST. Now next is, what are the benefits of DAST tools? So let's see. uh, that is, first, it is language agnostic. So regardless of SaaS tools, if you remember, SaaS tools would have limited types of languages. So it would provide for C++, C sharp, and Java, JavaScript, Python, Ruby, and all these different languages. But if there is no data about certain different language or new language, then how would you test that? Okay. So that's why here DAST would perform directly on the served application or the running application. So it does not care about what language you are using in the backend. It would just test your output and the responses, and then okay, it's done. So works regardless of the programming languages or frameworks used. Now it would do a real world testing of your applications, and what it does is identifies exploitable vulnerabilities from a user's perspective. So as you are using this application, it would test your application based on that. So that's the major difference and benefit that we get out of DAST. Now, no access to the code is required. So if you want to have a third party vendor or third party, person do security testing on your application, so you need not give you do not need to provide access to them. You can just say, okay, use this environment, and this is the link where application is running. Now you can test it on your own. So it is ideal for third party or legacy apps where source code isn't available. So I can try it on this one, the GitHub as well. I do not have the code of this application, but I can try doing it, okay, on this application if I want to run it, run a DAST scan against it. So that's one way. Okay, cool. Next is continuous testing. So it can be integrated into CI/CD pipelines for ongoing security validations. So you can run it through CLI commands and add it in your CI/CD, and then it identifies misconfiguration. So now, as I mentioned earlier, the application is running on certain servers, right? So it would detect if the server is also containing any kind of misconfiguration or if there are any vulnerabilities on this server. So uh, it would only detect all these things in the runtime. Okay. So code, by looking at the code, you cannot get the entire context of how the application runs. It would just show weaknesses in the code. But when it comes to running application, then you need to see, as I always give you the example of plane. So if it is there in the standing state, you can see, okay, the nut bolts are tight, the wheels look intact, the flaps of the airplane is good. But if it is in air or is it in water, okay, how do you decide where it is running? And how would you test that in different cases? So that's why it is important to test any application or any product in the runtime environments. So that's what we we do over here. So then what are the limitations? We got to know about the benefits, how it works, and all the other things. Now let's talk about what it cannot do. The DAST tool cannot see the internal logic, as I mentioned or earlier. It cannot detect issues in logic or unreachable code. So let's say if there is a code that is written, but it is unreachable and it is used somehow in your application. So it cannot test that one if that is vulnerable or not. It can only see what is being presented in the running state or to the user. So that's what it does, nothing else than that. Now it is again slower than static code tests. Okay, so it requires a live environment, and it takes longer than SAST. So obviously, if you are kind of looking at the blueprint or the book of the aeroplane, it is easy to check these things, but it is really hard to check the aeroplane when it is flowing in the air. Okay, now you may miss some vulnerabilities as a part of DAST, especially if input URLs are hidden or required special authentication. So somehow, we can add some authentication methods as well. But if there are something else which requires ongoing captcha or anything else, then it would, fail in that particular case. Not fail, but it would miss those vulnerabilities checks. So that is one, drawback of using dash tools. Next is harder to cover full application. So as I already mentioned, dynamic crawling may miss deep or more complex paths. So here you will need to do some manual testing as well. Okay, manually you can hit certain application URLs, and otherwise you would miss this out. So if there are dialog box and then there are input fields and again there is click button, so it would miss those kind of things. So that's why you need to somehow try to do it manually as well using the same dash tool itself, but automation would work in a different way and manual dash tool would work in a different way. Next is it may cause side effects. So could impact live system if run on production environments without precaution. So as you know, it would try to inject certain kind of malicious inputs. So if the application breaks and application overflows, so what will happen? It could probably cause a crash of the application, and it would stop the entire application when it is running on a production environment. So we need to always test applications using dash tools in a isolated environment or development environment, so to say. So you don't need to worry about production environments getting down due to certain payloads that the dash application send to it. Next is different popular dash tools that are used in the organization worldwide. So here you can see OWASP Zap is one stuff, Burp Suite is another. So we will learn how we can attack an application using Zap and how to remediate the findings. We would also, if time allows, we would see Burp Suite, then Acunetics, NetSparker, AppScan, GitLab Dast, Black Duck are different kind of vendors you can see all over the world, which are providing these dash capabilities. So that is one thing you need to know. So either you use one or two, it is good for you. So you need to have an hands-on experience on this particular kind of tools. So that's one more thing. And next is what? DAST versus other security tools. So let's see what do we get over here. So I would like to keep it here. So we will compare it against SAST, IAST, and SCA. As you already know what we are doing. IAST is Interactive Application Security Testing. So IAST is what we are going to see in some future videos, wherein we will talk about what is it, what are the different you know uh, vendors provide IAST capabilities. So feature analyzes running app. So DAST does it, SAST do not. Then IAST okay, and then SCA does not do it on the running application. Then access to source code required. Okay, so we do not require any access to source code in the DAST. We require it in SAST. We do not require it in SCA because SCA would only look for the packages that are mentioned, and then IAST would obviously require the uh, this visibility into the source codes. Then is it a language dependent stuff that we are looking? So you know as we mentioned, DAST do not care what language it is. It would just attack your application right away. Then for SAST, we know we require this thing. For IAST, we would require. But for SCA would also again do not require. A package is a package. It doesn't matter if it is Python package, NPM package, or anything else. Now next is finds real world exploit. So yes, DAST is very helpful in finding out that. Then SAST would not find out anything. IST would give us, and then SCA would not give us anything. What are the different tools? Zap or burp suit, sonar cube is for SAST, okay, contrast invicti is for IST, and SCA is sneak, backduck, dependency check, and other stuff. So here you can see what what things do you see in are covered in most of I mean what is the methodology that covers a lot of these things. Okay, you can see DAST is having some capabilities, some are not. Okay, SAST is also having some capabilities. SCA is also having certain capabilities, but it does not provide everything. But IAST, okay, IAST is the one that gives us all of these things. Okay, that gives us the results from running application, from the source code. It is going to check the languages, and it is going to find real world exploit. So this gives us the entire picture. That is why IST tools are also more important, you know, apart from SAST, SE, and DAST tools. So that's why companies like very few companies would kind of adopt IST, because these services are really expensive, and they kind of have a very sophisticated way of working. So that's the reason you would mostly see SAST or DAST or SCA applied in major organizations, but not IST. So we will cover IST in our later videos, as I mentioned. For now, as we would move to another slide and see uh, where we are right now. So in our previous videos, we have covered threat modeling, we have covered SAST, we have covered SCA, we have also covered some part of secret management or secret detections, and today we have covered DAST. So I hope you got to learn about the differences between these three, okay, as well as IAST. So IAST again is a topic of later videos. So we will, I mean, I hope you would keep in touch until we reach to that particular point. So that's what we have for today. And if you like the explanation and all these things, you can always hit the like button, share it, and subscribe with your people, those who are kind of trying to learn DevSecOps. So um, and yeah, in our next video, we are going to learn about what is OWASP ZAP and how can we use OWASP ZAP to test a sample application. Let's say we would get a vulnerable application, and then we would test it against this dash tool, and let's see how are the vulnerabilities detected, and how we can report, I mean, generate the report out of it. So that's what we will learn. So I guess that's all for today, and see you guys in some another video. And of course, in the next video, we will learn about uh, what is the roadmap for DevSecOps. So I forgot to mention that one. We will look into it as well. So for now, keep learning, and see you in the next video. Bye, guys.